Now, for the area of parallelograms, things are a little bit different. For perimeter, no matter what shape it was, you just add all of the sides together. But for the area, for all parallelograms, doesn't matter if it's a square, rectangle, or a different type of parallelogram, such as this, it's always going to be base times your height. Or another way you could write it is A equals BH. That's the typical way you're going to see formulas written. A equals BH. For this, all you have to do is find the base of the parallelogram, the height of the parallelogram, and multiply them. Unlike perimeter, where you're going to find the length of all of the sides and add them up. For area, all it is one multiplication problem. In the case of our square, if you recall, all 4 of the sides are the same. So my base is going to be 3 and my height is going to be 3, giving me my area of this square to be 9. For this rectangle down here, we've got a base of 6 and a height of 2. To get the area of this, simply do 6 times 2 and you'll get an area of 12. And lastly, over here for this parallelogram, you're going to have to use only 2 of these numbers in order to find the area. So, take a look at this 6. Does this look like it's going to match up with my base down here? It will. This 6 will match up very nicely and be equal to my base down there. However, at this point we're going to have to really consider, are we going to use this 4 as my height, or are we going to use this 3 as my height? If you said 3, you're absolutely right. If you said 4, let me demonstrate something for you real quick. This is a measuring tape. This is what I'm going to use in order to measure my height. I'm going to do it one of 2 ways. The first way, I'm going to find it the same way that this parallelogram found its height. I'm going to take this measuring tape. I'm going to step on it on the bottom with my foot, hold it up to my head, kind of mark it with my fingers, and I am more or less 5'11" and a half according to this measuring tape, holding it straight up and down like that. Now let's take a look at the way the parallelogram found this right here. I'm going to hold it right up here to my head, and I'm going to go diagonal all the way down until it touches the floor, however far I have to go. Okay. It is now a perfectly straight line from the top of my head to the bottom of the floor. So let's see. Now when I measured it, I am 7'1". That creates a bit of a problem. If you look at this parallelogram, it has 2 things that are supposedly measuring the height. One of them is a trick, the other one is the actual height. The number that is being represented by this line that is cutting down the middle of the parallelogram is the real height. This 4, the fact that it's going sideways or diagonal, means it can't be used as the height. That's just not how height is measured. To measure height, you have to be going vertical, straight up and straight down. To measure the base, likewise, you have to be going straight across and straight back. It can't be diagonal. The base has to be flat and the height has to be vertical. Plain and simple. So for the area of this parallelogram, we are going to take our base, which is 6, and our height, which is 3, to get an area of 18. Now before some of you go nuts telling me that this shape does not work, this shape can't work because if I were to take the base of this, it's not matching up with the base at the top. Well, that's where you're wrong. If I were to draw a nice neat triangle, or as nice of a triangle as I possibly can, given the fact that I have absolutely 0 artistic ability, I can take this triangle and place it over here on the other side of this parallelogram, and well, you can imagine that if I had any artistic ability whatsoever, and I took this completely off and moved it over here, I would suddenly have a perfect rectangle with a base of 6 and a height of 3. I wouldn't need that 4 anymore. But frankly, it's way too much work to try to draw a triangle and reconfigure a shape every single time you want to do it. So for now, understand that a parallelogram is simply a shifted over rectangle. You still have a base, you still have a height, but don't be tricked. Do not fall for the diagonal. Before we move on to the area of triangles and other shapes, I just want to touch base on the way that you would handle the units of measurement. Before I was simply saying 6 and 3 and 4 and 18. Well, that's not how things are usually going to work. Typically, there will be a unit of measurement along with those numbers. In this case, I went ahead and threw in inches and feet for some of these shapes. In the case of this square, if I have a 3-foot by 3-foot box, and I were to find the square footage of that box, I'm going to end up with a square footage of 9 feet squared. Now, a lot of times my students will ask me, why is it squared? Why is this represented by a 2? And I came up with this little solution. Using this little whiteboard, I decided that I was going to try to find the square inches of this board. The reason we call it square inches is we're trying to find out, more or less, how many squares that are 1 inch by 1 inch fit on this board. Now, of course, I am no art person. This is about as good as I can do. Don't expect to ever see any works of art on this channel. But I thought that that would be a pretty decent way of showing why is everything measured in square footage as far as area is concerned. For this rectangle, that would mean 6 inches times 2 inches gives me 12 inches squared. In the case of my parallelogram, 6 inches by 3 inches is going to give me 18 inches squared. We're all set on that? Okay, we're going to move on now. So next up come the area of triangles. Triangles are a little bit different in that you have to take the base, you have to take the height, and then you're going to have to divide by 2. This could also work by writing it as BH divided by 2, or you could say that you are multiplying half times your base and height. Okay? So in the case of this right triangle right here, we're going to take the base, this nice flat even surface on the bottom, and our height. If you think back to the previous slide, we were talking about the fact that a diagonal line will not work as your height because that is not an accurate measurement of how tall something is. You must find a vertical line. Usually this will be represented by a right angle box, this little indicator right here, showing you that that is indeed a right angle. You'll find the 2 lines connected to this right angle indicator, in this case 10 feet by 12 feet, and you will multiply them the same way you would for a parallelogram. However, if you were to do 10 by 12, what you're really doing is finding the area of this shape. If you do 10 times 12, you just found the area of this square, or this rectangle. That's why you have to do divided by 2. You have to do 10 feet times 12 feet, and then divide it by 2. And that's going to give you an actual area of about 60 feet squared. We're still using square footage. Even though we're finding the area of this triangle, it's still represented by how many square feet can fit inside of that triangle. In the case of this isosceles triangle, we have a base of 8, and we have 2 numbers right here. We have one that is slanted, the one we will not use, which is 15 feet. Then, inside of this triangle right here, I've drawn a little dotted line represented with this little 90-degree indicator, and it says that the height of it is going to be 12 feet. In this case, we're going to take our base of 8 and our height of 12, multiply them together, and we'll have an answer of 96. Once again, this 96 is not our final answer. We've done base times height, we still have to divide by 2. 96 divided by 2 is going to give me an answer of 48. I'll go ahead and write that in here, 48 feet squared. Gives us that answer. Let me circle that previous answer too. Finally, for this triangle, we have a base of 15, height of 10, and a trick of 12. We'll take 15, multiply it by 10, then divide it by 2 to give us our final answer of 75 centimeters squared. Okay? This is more or less how it's going to work for every triangle. There will be a few cases where the indicator for the height will actually be listed over here. Usually, the way I've seen it written, is they'll have a little bracket sitting on the outside of the triangle. And that's generally the only other way that they're going to represent the height for you. And just to go back on that previous point, that when you multiply base times height, you're really finding the area of a parallelogram, think of that for every triangle. Every single triangle, no matter its shape, no matter its size, is only half of another shape, a parallelogram. This is why you always have to divide by 2. I just thought I'd put up this little example so you could see this right triangle is half of a rectangle. This isosceles triangle is half of a rather thin and tall parallelogram. And this other triangle, I believe I drew it to be an equilateral triangle, is just half of an ordinarily shaped parallelogram.